Let's now do an example of a projectile, and we will say that we have from the ground level we are shooting a projectile at an angle of 30 degrees with an initial velocity of magnitude 20 meters per second. So V initial is 20 meters per second at 30 degrees. Okay, so we shoot it off at that angle with that speed, and it will go and hit the ground somewhere. This is X initial, Y initial, this is X final, and we want to find the distance X final. How far does it go and hit the ground? So X final is what we are looking for, and we also want to find the T. How long did it take to go from initial position up to the final position? So now we can first make a list of what we know, and then a list of the equations, and then pick up the correct equation. So we know X initial is 0, X final is unknown, Y initial is 0, Y final, well, it's on the ground level, so this is Y final is also 0. V initial in the X direction is going to be V initial cos theta, so that's going to be 20 cosine 30, 17.32 meters per second, and V initial in the Y direction is going to be VI sine theta, so 20 sine theta, so 20 sine 30 is going to be 10.0 meters per second. Then the acceleration in the X direction is 0, the acceleration in the Y direction is minus 9.8, T initial is 0, and T final is what we are looking for. Now, normally in these problems we use the Y equation to get time, and we use the X equation and the time to get the displacements. So we can just straight away use the Y equation. We can check it out, but it's going to come out to be like this. So we can say that Y final is Y initial plus VIYT plus half AYT square. Y final is 0, it's on the ground level. Y initial is 0. V initial in the Y direction was 10.0 meters per second. T is what we are looking for, half, and A is minus 9.8 meters per second square, T squared. So this gives us, by a little rearrangement, 4.9 T squared minus 10T equals 0. Now we can factor out the T, 4.9 T minus 10 T is 0, and this gives us two solutions. T is 0 and T equals 10 over 4.9, which is 2.04 seconds. So we have one answer here and one answer here. So mathematics gives us two answers, and we need to pick up the correct one from physics. Well, we find that both answers are correct. At this point, T is 0, and this point, T is 2.04. Both of these points have Y equal to 0. Here also, Y equal to 0. So we had substituted Y equal to 0, and we got two answers, and both of them are correct. This is the one that we're going to take. So we got this as 2.04. Now we look at XF, and we can use the X equation. X final equals X initial plus VIXT plus half AXT squared, and this term is 0 because AX is 0. X initial is 0, VIX is 17.32, and the time is 2.04 seconds. So in 2.04 seconds it travels 35.34 meters. We can round it to 35.3 meters. So that's how far it would go. 35.3 meters. Now if we add up a little bit more to the question, so we got this answer and we got the t. So if we say, okay, what is the maximum height, which is right in the middle, okay, so that will be at xf over 2, so right in the middle, what is the maximum height to which it goes? Now we can use the y equation, this equation, and use t as half of this time, half of 2.04, but let's suppose we don't know this time. So first we'll find out the time here, which will come out to be half of this, half of 2.04, but let's suppose that we don't know that. So we'll find the t for here, and once we have the t, we can find the x, which is half of xf, and we can then find the y max. So to get that, we use v final y equals v initial y plus ayt. Now v initial y we know is 10 meters per second. This is minus 9.8. T is what we're looking for, but what is vy final? At the highest point, the projectile is moving purely in the horizontal direction, and vy final is 0. There is no y component of velocity because it's purely horizontal. Will be the same as what it was here. It's going to remain the same everywhere. But at that point, the vy is 0. So this is 0. And this will automatically give us the highest point. And therefore, t is going to be 10 over 9.8, which is 1.02 seconds, which is half of what we had before. For here, it was 2.04 seconds. This will be 1.02 seconds. Now that we have the t, we can find the y. How we can find this height? So y final equals y initial plus v iyt plus half ayt square. Y initial is 0, starting from the ground. V initial y was 10 meters per second, 1.02 plus half minus 9.8. 1.02 square is our y final, which is the y max, and on solving this we get 5.10 meters. So that's the maximum height to which it goes. This will be 5.01 meters. Now we have two more equations which are called the range equation, written as an r, and that is given as a v initial square sine 2 theta. So 2 theta is one thing over g, and we have a height equation or a maximum height equation, which is vi square sine square theta over 2g. Now if you want to use these equations, we'll do that to verify what we had got. So this is the h and this is the r. So x is 0, x is r, and this is the maximum height. So for our problem, r would be v initial was 20 square sine of 2 theta, so that was going to be 2 times 30, so it's sine of 60 over 9.8. And when we solve this, we get 35.4 meters. It's very slightly different from what we had before. We had 35.3, and that's because of rounding. We did some rounding over here. And the height equation is vi square, so that's 20 square sine square of 30 which is 0.5, so 0.5 square divided by 2 times 9.8, and that gives us 5.10. So we get the same answers by these equations. Now, these equations, especially the range equation, should be used with care, because if we have a question, for example, the same question, you had the ground here, and you had a building, and you shot it from the top of a building with the same speed, 30 degrees, and we want to find how far it falls on the ground. So this distance is x final, and it is not equal to the range. The range would be up to here. This will be r. So in this equation, you have to be at the same level, okay, same horizontal level. So r would be from here to here, okay, from initial to this point, but not xf. So it's better to use the equations of motion, because they will apply. And if you want to use the height equation, it's going to give you this value. Okay, it's not going to give you the height from the ground, so you have to add this distance to it. Now, using these equations, we can, the range equation and the height equation, we can see that the maximum range would be when sine theta is maximum, when for a given velocity the range is maximum when sine 2 theta is maximum, and that will be for sine 90, which means theta is 45 degrees. So at 45 degrees it's going to cover the biggest distance, and the maximum height would be when this is 1, which is at 90 degrees. So when you shoot it vertically up, it goes the highest distance, yeah, and at 45 degrees it goes the farthest. Again, this is true only if it's on the ground level. For this case, the biggest distance is not at 45 degrees. It's going to be somewhat smaller than 45 degrees.